This video is looking at factorising quadratics. We've looked at expanding them before using the FOIL method. So that is first, outside, inside, last. Expanding that would give you x squared plus 5x take 3x take 15. You'd combine the like terms and it would be x squared plus 2x take 15. The idea is to factor quadratics, you would be first given this equation, 3 terms, one with an x squared term, one with just a single x term, and then one with just a number, and you need to get it back into factorised form. To factorise this expression, we need to find all the factor pairs of the C term that add to this term. I'll show you why. So let's look at all the factor pairs of 6. You could have 6 and 1. You could have 3 and 2. You could have negative 6 and negative 1, you could have negative 3 and negative 2. You can see that 6 and 1 added together equals 7. 3 and 2 added together gives you 5, so this is going to be the right pair. Negative 6 and negative 1 added together is negative 7, and negative 3 and negative 2 added together is negative 5. So our pair of factors that we are looking for is 3 and 2. We can simply then go and put that back into our brackets as x, it's a positive 3, and x as a positive 2. Always good to go and check your answer at the end to see if it is correct. So x, use the FOIL method this is, x times x is x squared, x times by 2x is 2x, 3 times by x is 3x, add those together gives you 5x, and then 3 times by 2 is equal to 6. So you can see that that is correct. Let's now look at this second quadratic equation and try and factorise it. So we're looking for factor pairs that multiply to negative 30, but add to the coefficient. In this term, there is none, meaning it is negative 1. So there is an imaginary 1 there. So we need numbers that multiply to negative 30, but add to negative 1. So could be negative 6 and positive 5, or it could be 6 and negative 5. None of the other factor pairs I don't think will work, so it could have been negative 10 and 3, or negative 3 and 10. 15 and 2 is not going to work either, negatives or positives. So let's have a look. Which ones add to negative 1? Negative 6 and 5 add to negative 1. 6 and negative 5 add to positive 1, so it won't work. So those are our factor pairs. Now all we simply need to do is pop it back into brackets. So x negative 6, x positive 5. Check the answer by using the FOIL technique. So x times by x, x squared, x times by 5 is 5x, then negative 6 times by x is equal to negative 6x, so we combine those terms to give us negative 1x, and the final term in the expression, negative 6 times by 5 is negative 30, so you can see that is correct. Sometimes you'll come across quadratic equations like this one that have no middle term, so no single x term. The key to look for is to see if they are both square numbers. So in this case, you can see that x squared is a square number, but 16 is a square number. Usually the factors of 16 is 4. So 4 and negative 4 multiply, you can see, to get to negative 16. In this case, we can use a rule called the difference of two squares. So if you actually go and write x plus 4, x take away 4, and you did the FOIL technique, x times by x, x squared, x times by negative 4 is negative 4x. 4x times by 4 is positive 4x. So those single x terms would cancel out if we were to expand it. X squared, 4x, negative 4x, and then multiply the last two terms together, negative 16. Therefore, these two terms would cancel out, leaving us with x squared take 16. So simply, if you see one that has two squares, you can apply the difference of two square rule by making the factor that is the square one positive, one negative, and pop it into the brackets, like so. Yet again, you could check your method using the FOIL technique.